This is lesson 1.4, which is on ordered pairs. I would suggest pausing this video and working through these warm-up problems on your own, and then we'll go through them. So for both number 1 and number 2, we are going to simplify the expressions. So looking at number 1, we have 7y times 3. Well, using that associative property of multiplication, we can change around where the parentheses are. So instead of doing 7y times 3, I can change this to 7 times 3 times y. Now that I have that 7 times 3 in parentheses, I can multiply those together. 7 times 3 is 21, and then times y. The only way to write this simpler is to just write it as 21y, because when we have both a number and a variable, we don't have to put anything in between them. When we're multiplying, I should say. Number 2, 33 plus f plus 17, we can use the associative property of addition and switch this up so we can do 33 plus 17 in parentheses plus f. Then I can combine 33 plus 17, which is 50 plus f. I can't combine those because they aren't like terms, so that is my answer. Number 3 says to rent a popcorn machine, it costs $35 plus $7 for each hour. Write an expression to find the total cost of renting the popcorn machine. So with this, we know that it costs, whoops, that's not a highlighter. It costs $35 plus $7 for each hour. So that $35 is going to be a one-time fee. We have to pay $35 no matter how many hours we rent this machine for. And then every hour we also have to pay $7. So to write that, we can write that as $35 plus, and then 7 times x, and that's going to represent the cost we're paying for all of the hours we rent the machine for. Further on into the year, we are going to switch how we write this around, and we're going to write it with the variable and the number first, and then that constant number by itself at the end. So writing this as 7x plus 35. It's good to get in the habit of that. Then letter B says evaluate for 5 hours. So all we're going to do is we're going to plug 5 in for x and solve. So 7 times 5 plus 35. Then following order of operations, I have to multiply first. 7 times 5 is 35, and then I still have that plus 35. 35 plus 35 gets me 70, but since it's a word problem, I have to answer this in a sentence. So I'm going to write, it will cost.
Any staff that has students up to age 18 can go to the cafeteria and get meals.
$70. Excuse that announcement on the speaker.
Staff that has students up to age 18.
So here is some vocab. We are going to label, so in your notes, you have this coordinate plane laid out as well. So we're just going to label some of these vocab words. So coordinate plane is this grid here. So we can label that. An ordered pair is written as x and y. So here is an ordered pair. The origin is the point 0, 0. So the origin is that dot where both the x and the y axis meet. So that's the origin. The x-axis is going horizontally, and the y-axis goes vertically. An x-coordinate always comes first in an ordered pair. The y-coordinate always goes second in the ordered pair. So in this case, the 3 is the x-coordinate and the y is 4. So to graph ordered pairs, we first go left or right for x, and then we go up or down for y, depending on if it's positive or negative. So looking at letter A, our x is 3 and our y is 4. Since it's positive, we start at the origin, always start at the origin, and then we go 3 to the right and 4 up. We plot our point, and then we always label our point. The next one, letter B, we have 0 for x, 2 for y. Again, we're starting at the origin. We don't have to go left or right because we just stay at 0, and then we go up 2. Since y is 2, plot our point and label it as b. Letter C, we have 2, 5. Again, we go x and then y. So x, we're going to go to the right 2, up 5, plot our point, label that as C. And then last but not least, we have 4, 0, which means we go to the right 4, and 0 is y, which means we don't go up or down, so we just keep it on the x-axis. So again, we need to label all of our points. Okay, then this is the opposite. We're going to write in the ordered pairs for these coordinates on our coordinate plane. So starting with letter A, we're going to start with our x value, how far left or right we have to go. Well, in this case, we only have to go up, which means our x value is 0. And then our y value is how far we have to go up. So we have to go up 1, 2, 3, 4, 5, 6. So letter A, that ordered pair, is 0, 6. And we always write a comma in between. Letter B, we have to go to the right 1, 2. So our x value is 2, and we have to go up 1, 2, 3, 4. So our y value is 4. And put a comma in the middle. Letter C, we have to go to the right 1. So x is 1, and we have to go up 2. So y is 2. And lastly, letter D, we have to go to the right 1, 2, 3. So 3 is x, put a comma, and then we go up 1. So our y value is 1. So just some more vocab. A relation is a set of ordered pairs that can be shown in a table or a graph. So here we have the ordered pairs, we have them written as a table, and we have them shown in a graph. So the biggest thing here is domain and range. Domain is all of our x values in order from least to greatest. Our range is all of our y values in order from least to greatest. So domain is our x values, and range is our y values. So when we look at our x values here, we have 1, 2, 3, and 0. We put them in order from least to greatest, so our range is 0, 1, 2, 3. For our y values, we have 4, 2, 0, and 2. So 0 is our smallest, and we only have to write each of the numbers once. So if there's multiples of a number, you only have to write it once. So we have 0, 2, 4. And then in our table, we just have our ordered pairs broken up by x and y. So 1, 4, 2, 2, 3, 0, 0, 2. And then when we graph those ordered pairs, so for example, if we were graphing 1, 4, we just go to the right 1, up 4, plot our point. So this problem says express the relation 4, 1, 3, 2, 0, 1, 2, 3 as a table. Then determine the domain and range. So I'm going to make a table here. X and y values. So the first ordered pair, I know it always goes x, then y. So our x is 4, our y is 1. The second ordered pair, remember the x is always first, so we have 3 as our x, 2 as our y. For 0, 1, we have 0 as our x, 1 as our y. And for 2, 3, we have 2 as our x, 3 as our y. So all we did was we took those ordered pairs, broke them up into a table of x and y, and then we need to determine the domain and range. So remember, the domain is all of the x values sorted from least to greatest. And we do domain with these fun little squiggles and then the numbers in between. So 0 is our smallest, then we have 2, 3, 4. And again, oops, I forgot my little squiggle there. I got my domain values from my x column. Then for my range values, I'm going to take the y values and sort them from least to greatest. So I have 1, 2, 1, 3. Since there's 2 ones, we only have to write that down one time. So we have 1, 2, 3. And remember, my range values are all of my y values. So here's an example where it says Jose earns $5 an hour doing yard work. Make a table of ordered pairs in which the x-coordinate represents the hours worked and the y-coordinate represents the amount of money he earns in 1, 2, 3, and 5 hours of work. So here we have the x-coordinate is the hours worked, and the y-coordinate is the amount of money he makes. So he earns $5 an hour, which means in 1 hour he'd make $5, in 2 hours he'd make $10, 3 hours he'd make $15. So our rule here is 5 times x, 5 times however many hours that he works. So I'm going to write that in for the rule column. Then my inputs, remember, is the hours worked, and we're told to find how much money he makes if he works 1, 2, 3, and 5 hours. So I'm going to fill in those for my x values, 1, 2, 3, and 5. Then I'm going to plug those into my rule and get my output, or my y value. So first we're going to take 5 times 1. 5 times 1 is 5. Then I'm going to take 5 times 2. 5 times 2 is 10. Then I'm going to take 5 times 3. Again, I'm just plugging in that x value for x. 5 times 3 is 15. And then I'm going to take 5 times 5, which is 25. So now, letter B says to graph the ordered pairs and describe the graph. Well, here's the deal. We can create ordered pairs because we have x and y values. So the first ordered pair would be 1, 5, because 1 is the x, 5 is the y. Second one would be 2, 10. Third one would be 3, 15. And the fourth one would be 5, 25. So now we're going to graph those ordered pairs. So remember, our origin is where those 2 lines meet. We are going to figure out, so let's look at our x values first, because we're going to put our x values on our x-axis. So we have 1, 2, 3, and 5. So I'm going to do every other line here as 1. So I'm labeling that 1, 2, 3, 4, 5. And that's the hours. We're labeling that x-axis. And then we have 5, 10, 15, 25 as our y values. So I'm going to do every other one as 5. 5, 10, 15, 20, 25. And then I'm labeling my y-axis as money. So my first ordered pair is 1, 5. So I go to the right one, up 5, plot my point. Second ordered pair is 2, 10. So I go over to 2, up 10, plot my next point. Then I have 3, 15. So I go over to 3, up 15. And the next one is 5, 25. So I go all the way over to 5, all the way up to 25. And there are the 4 of my ordered pairs. Then it says to describe the graph. So here, there's so many ways we could describe this, but we could say it goes up diagonally. Because if we were to connect those, and I can never spell diagonally, so don't judge. If we were to connect those, it would make a diagonal line. And then the last one here is Sue is following a recipe for cookies which requires 2 cups of sugar for each batch of cookies she made. X represents the number of batches made. Make a table for ordered pairs in which the x-coordinate is the number of batches and the y-coordinate is the number of cups of sugar. So we know x-coordinate is number of batches, y-coordinate is cups of sugar. And we're given values for the x-coordinates. So our rule here, we know it's 2 cups of sugar for each batch. Each is multiplication, and our batches are going to change, so that's going to be our x. So our rule here is 2x. So we can fill in 2x for our rule. And then we have our batches is our x, and we know there's 1, 2, 3, 4, and 5 batches. So we can fill in those for our x values. Then we can plug those x values into our rule and solve for y. So 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. And 2 times 5 is 10. So now I have my x values, I have my y values. I'm going to write these as ordered pairs, and then I'm going to graph them. So remember, ordered pairs are written as x then y. So our first ordered pair, the x value is 1, the y value is 2. Then we have 2, 4, 3, 6, 4, 8, and 5, 10. Now that we have our ordered pairs, we can graph them. So I look at my x values. We have 1, 2, 3, 4, 5. So I'm going to label my x-axis. I'm just going to do every line as 1. And then my y-axis is 2, 4, 6, 8, 10. Again, I'm going to label every line as 1. If it'll let me here. There we go. And then I have to label these. So I know my x coordinates are numbers of batches. So I can write that as batches. And my y coordinates is sugar, cups of sugar. And then I'm just going to plot these points. So my first ordered pair was 1, 2. So I go over 1, up 2, plot my point. Next one was 2, 4. Go over 2, up 4, plot my point. Then we have 3, 6. Over 3, up 6. 4, 8. Over 4, up 8. 5, 10. Over 5, up 10. And there we go. And then it says describe the graph. So again, it goes up diagonally.